Okay, so we are going to do NBMA, OSPF, NBMA network types. So it is not only for NBMA, it is also used in an broadcast environment to 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 have those features that is available in NBMA network modes. NBMA, OSPF network types. Now, I'm simulating an NBMA with a frame relay in the middle. This is actually a router. A Cisco router can be configured as a frame relay switch. Yeah, you can configure it as a frame relay switch. Though it's an older technology, we need this to understand the NVMe types well. Secondly, the configuration of NVMe, it is not that easy as we do OSPF configuration or something like that. So you need to focus. Second, thirdly, I want to say that it's not so important to learn the configuration of frame relay. As much as you understand the logic, how it works, that's enough. But if you can grab completely the frame relay, good. But it's not important for now. Earlier it was. And the video is going to be there with you. So if you really want to master that, you can do that. Now we have a question. Question is, we got serial links. We learned in theory that NBMA network type broadcast, non-broadcast, which is network type 1, the first one, the default. Whenever we connect the serial link to frame relay, we run encapsulation type frame relay. And we saw neighborships are manually configured. The neighborship don't come automatic. The neighbors are not dynamically discovered. We saw that neighbors need to be configured manually. Whereas in the second type, point to multi-point, the neighborship comes dynamically on the same serial wire, on the same wire where the encapsulation type is frame relay. This is the question. It's the same encapsulation type, it's the same frame relay and same serial wire. How is that possible for point to multi-point to dynamically discover neighbor, whereas in non-broadcast manually need to be configured? For that, answer is this. You see, in order to have variation, the industry standard has designed it like this. The first one, the non-broadcast, is not supposed to use 224.0.0.5, the multicast. Whereas point to multipoint is allowed to use that multicast address. As a result, the point to multipoint can send hello packets over the frame relay PVCs. Frame relay tunnels are called as PVCs. Using that hello packet, the neighbors are discovered. The hello packet is possible because you have multicast address. We did not configure neighbor manually. So hello packets are sent to a multicast address. Whereas in the first one, non-broadcast, multicast is not allowed. So only when you give manually the neighbor address, the hello packets will be sent as unicast over the PVC. Even here, the hello packets are sent to discover neighbor, but it is unicast the address to which you configure as neighbor manually. So in order to have variations, we need to do something. That something is this. For non-broadcast, no multicast 224005 is allowed to use. For point to multipoint, it is allowed. Did I answer the question?
So it means to keep the industry wanted, like they want on top of the LDMA environment, they wanted the leadership automatically. So this is the reason they put this point to multi-point environment. Is it answer?
Correct. So industry needs different type of uh, approach. So in order to derive those approach, they have made they made this differences so that we can use any one of this,
Okay,
and
got it.
and it is called a standard so that everyone knows what non-broadcast means, what point multi-point mean. So when we have a discussion, when we say point to multi-point, anyone on earth will know, okay, the neighbors are dynamically discovered and there is no DRPDR election. Hmm. So when we say non-broadcast, everyone knows that there will be a DRBDR and the neighbors are manually configured. We all understand and we are in same sync because it has made standard. Yeah, fine. Now I'm going to go to all these four routers, the green one, not in the middle one. The frame relay will do later. Firstly, I want to go to these four routers, all these four routers, and configure frame relay OSPF with IP address. All right. So let me start from router one. On router one, when I say interface loopback 0 and put this IP address 101.1.1.255.255.255 IP OSPF 1 area 0. IP OSPF 1 area 0. So now this interface loopback is included in area 0. Secondly, interface serial 6/0 IP address 10.1.0.1.255.255.000. And now here also I'm going to enable IP OSPF 1 area 0. Please focus, please focus. When I say here now, show IP OSPF interface serial 6/0, you will see the OSPF network type as point to point. This is default. When the encapsulation type is HDLC, this is what it will show. The encapsulation type is HDLC, that's why it shows point to point. Let me show you that part. The encapsulation type is HDLC. You see, when the encapsulation type is HDLC, the OSPF interface will be network type point to point, point to point. And the hello timers are 10 and 40. This is not frame relay, but when I go to the interface serial 6/0 and say encapsulation is frame relay, not HDLC, when I change to frame relay, see what happens. You see, I have changed the encapsulation type to frame relay. All right, so lot of changes on the interface, the trans receivers, the LMI, DELC numbers, data link connection identifier, local management identifier, all this comes into picture. LMI type is Cisco, all this comes automatically. Those are all frame relay related. Frame relay is running on serial 6/0. Now I want to show you what is OSPF calls it. OSPF calls it as non-broadcast. Look at this. It's the same serial wire. When the encapsulation type was HTLC, OSPF called the network type as point-to-point. But now it calls it as non-broadcast. And look at this timer. Earlier it was 10 and 40. If you want, I can show you again. Up, 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 up. 10 and 40. It's the same serial 6/0, which was showing point-to-point. Now, same 6/0 shows it as a non-broadcast. And the timers are 30 and 120. See, because it's a frame relay, you cannot keep on sending hello every 10 seconds, wasting the frame relay money. Frame relay, as I told you, it is very costly. And if you keep sending hello packets every 10 seconds, it will be like a waste of money. We waste the bandwidth by sending hellos. Instead of sending our packets, we send more of hello, which means what we are not using it for the right purpose. See, hello packets are important to maintain the neighborship, agreed, but not that often as you send in the LAN environment. In LAN environment, it's free, yours. You can send every 10 seconds, not a problem. But this one, for every single bit you pay. For every single bit you pay. So you cannot send every 10 seconds, so they made it as 30 as default and 120 as the daytime. But again, I'm telling you, if you wish to change this to something else, you can do that. The timers can be changed. You need to go under the interface and change the timer, which we'll do later. Now, our aim is to focus on NBMA network type. Let me do the same configuration, similar configuration, what I did in R1 on the other routers by using a notepad. To save our time, I'm using notepad. It's similar configuration, right? So enable config T interface loopback 0 IP address 2.2.2.2 IP OSPF area 0 interface serial 6/0 encapsulation frame relay, and then IP OSPF. That's all. I would like to paste this on router too. Done. Nextly, I'm going to go to router 3's configuration. For that, I'll put those configurations in this template. This is going to be 3 here. Done. Now, router 4. You remember I told you for all network types except point to point, the neighbors need to be in same subnet. See, everywhere we have 10.1 or 1 or 2 or 3 or 4 serial interface is 10.1. Now this needs to be pasted on R4. Done. Now these edge devices of various remote sites of various sites are ready. What is not ready is the internet, the middle, the frame relay is not yet ready. It is not ready. Now, I want to explain you a few things about frame relay so that you will understand the logic of how frame relay works. You see, now frame relay is tunnel. It's PVC, P permanent virtual circuit, PVC. So I'm going to put one PVC. Oh no. I'm going to put a PVC for R1 and R2, another PVC for connecting between R1 and R3, another PVC for connecting between R1 and R4. Now, is this full mesh? No. Listen, this is not full mesh. What is full mesh? You put another PVC between R2 and R3, another PVC between R2 and R3, earlier R2 and R4, now it is R2 and R3, another PVC between R3 and R4. Only then this will be called as full mesh. Everyone is connected to all. This is real full mesh. But if this is your head office, and frame relay is costly, these are not allowed. What frame relay people will do means, the company who uses frame relay will do is, they will ask this branch office 1 to come to head office and go to other branch office if they want. Because it is what? It is costly. There is no direct connection between the branch office. Not allowed because of costly. So if this is not fully meshed, then your network type should not be non-broadcast. But non-broadcast is the default. Why it should not be non-broadcast? Because the DR BDR will be elected, and if the DR goes down, you don't have these tunnels anymore, and there is no point of this becoming a BDR. Sorry, there's no point of another router which was an earlier BDR becoming DR. What is the use? So the non-broadcast is recommended only when you have full mesh. But we are not going to have full mesh because that will take a lot of time to configure tunnels, frame relay tunnels. Our focus is not configuring frame relay, but to an extent we will do it to understand this OSPF network type. So I'm not going to have full mesh, I'm going to only have hub and spoke. Same as what you see in this screen. Now to identify this tunnel, there is a number called del C number. What is that? del C, data link connection identifier. And this number I would like to give as 102 for this end of the tunnel. For this mouth of the tunnel, I would like to give 201. Likewise, this mouth I'll say 103, and this mouth I'll say 301. See, for our easy remembering, I'm writing like this. Don't think that I have to only put this type of number. I'm saying 124. That's why I say 104. And this is 421, so I say 401. This is for me to remember. There is no rules that you should only write this number. Now, this number will act like a MAC address. So what I'm going to do is I'm going to sniff Wireshark in between using Wireshark and see whether I'm able to capture frame relay. First of all, I need to check whether the frame relay capture is supported. Look at this. Look at this. Wonderful. We have it. Wireshark is the best. The best to learn. It's really a good tool. But I tell you, this is the first time in my life I know that Wireshark can support frame relay. Okay. Now you see the LMI type, local management identifier is going. It's going local management identifier. It's frame relay encapsulation type with the del C of 1023 DLC del C data link connection identifier. It is going, but don't go deep into these things. This is not our area, right? But good thing is you are able to see these things. Now, Q933A is not the one which we are running. We are using Cisco, but you are still getting some hello packets from Q933A. This was old. This is one of the option for LMI for negotiation of frame relay. You have Cisco, ANSI, and Q933. Let me show you that, but it is not important because it is coming on the screen. I'm showing you this because it is coming on the screen. Your brain may say, "Hey, what is this coming? I want to know." Look at this. LMI type is Cisco. Here, what you see is LMI type is Q933. It's one of the type. I would like to show you again. Interface serial 6/0. Frame relay LMI type. You see Cisco Q933A and ANSI. All right, but on Cisco routers, LMI type is Cisco. So no need to worry about that Q933. Okay, just forget about that. Now, I'm going to the frame relay switch itself. I'm on this router which is going to act as a frame relay switch. I'm saying encapsulation. Sorry, frame relay switching. This is the important command that you should type on the global mode if if you are configuring a router as a frame relay switch. Listen carefully. When you change a router to be a frame relay switch, it is not really changing a router to be a frame relay switch. It is still a router. Additionally, it is getting this frame relay capability. You are giving more responsibility. This is still a router. If you want to still use it as a router for some other neighbors, you can use it. But for these 4 routers, it is acting as a frame relay switch. It's going to act as a frame relay switch. Next is, it's again, I'm repeating, it's a frame relay switch. It's a frame relay switch. See how many times I repeated. Frame relay switch. Why I'm repeating this again? If it is a switch, it should be DCE, not DTE. This side it should be DTE. I would like to check whether this side is DTE. I want to show you. I know it is DTE, but I want to show you. On R1, when I show interface serial 6/0, you can see it as DTE. You see, DTE. On the other hand, this devices, the middle, the frame relay switch interfaces, the ports on the frame relay switch need to be DCE. So that is what I'm going to do first. Listen, interface serial 6/0, encapsulation frame relay, no shutdown, frame relay interface, frame relay INTF type. You see, you have DT, DC. I'm going to say DCE. Very important. Because it's a switch, it needs to be data communication equipment, not terminal equipment. It's not a terminal. R1 is terminal. Boom. I'm expecting something now in the Wireshark. Okay. Now let us move back again to the interface 6.0. Listen, on 6.0 we need to put a tunnel. Okay, the protocol has come up. Okay, inquiry is going on. Now, what I have configured so far in this interface, I have said DC, I have said encapsulation frame relay. That's all. Now, what else is needed? We need to say the del C number that we discussed. We need to say that whenever the tunnel endpoint is from 6/0 to 6/1, listen carefully. Whenever the tunnel is between 6/0 serial to 6/1, the local DLCI number need to be what? 102. The remote DLCI number need to be what? 201. That is what I need to do next. You see? Frame relay route command. Okay, let me show you this picture at the background and configure. Frame relay route. Right now I am under interface serial 6/0. So I need to say frame relay route IP, frame relay route. What is the local DLCI number? 102. That's the input, that's the local. And what is the output interface? It is serial 6/1. And what is the del C that will be configured there? 201. Boom. That is it. Now I'm expecting something new here because I have put one map. Permanent virtual circuit status. Okay, still not. Okay. The reason is the other side, this 6/1 is not at configured. That is why. Now I'm going to go to that other intro. Okay, wait. Let's finish all three VPN. Okay. Now first VPN is ready. Next, frame relay route. For the second VPN, 103. Exit interface is serial 6/2 301. Next, frame relay route 104 exit interfaces 6/3 and then 401. Come on, exit interfaces serial. Done. Now only one direction we have done. So if you check now, it will be inactive. Show frame relay route. You see, all three are inactive because we have just written only on one direction. 6/02, these three interfaces. But we have not done the other side. From 601 to 60, from 6/2 to 60, from 6/3 to 60, we have not done that. That is why it is inactive. So now let us go to the other side. Interface 6 serial 6/1. No shut. Encapsulation frame relay. Frame relay INTF type DCE. Frame relay route 201. Exit interfaces serial 6/0 102. Let me see if I see anything here. Anything interesting? Not it. But something interesting I can show you on the router side. Listen, one tunnel is really up. You see, 102 to 201 and 201 to 102 is active, which means, this is established. This is established. Now, if I'll ping from here, I'll be able to ping this. How is that possible? How router 1 knows that I need to send the traffic to 102? Why not 103? Why not this tunnel 104? If I ping if I ping router 2, it will go only to 102. But did I configure any map like that here on R1? No. But the map comes automatically. Let me show you that. On router 1, show frame relay map. You're going to see a magic boom boom. Look at this. It has discovered the remote. It has discovered router 2. To go to router 2, the DLC to which the packet need to be forwarded. This is the destination DLC. The source DLC will be 1023. That you can see on the interface. What will be the source? The source will be written somewhere here. The source DLC. I see DLC here. The source DLC will be dynamically assigned. Show interface serial. Show interface. Show frame relay. Okay, or you can also type show interface serial. Show IP OSPF interface serial 6/0. Even here you will see that I want to see the source DLC number. Source DLC number in capture I can easily show. The source DLC number is 10. Look at this 1023. That's the source del C number from where the routers are sending. But to which destination del C? It should send to this destination del C, which is 102. Only then it will enter into this tunnel, the first tunnel. It should not enter into 103 or 104. Why 103 and 104 is not discovered yet? It is because 104 and 3 tunnels are not really up, not ready yet. We have not configured this portion. So after we configure, we'll come and verify. Right now, only one tunnel is active. Let's move on the other side now. Interface serial 6/2. No shut. Encapsulation frame relay. INT frame relay. INTF type DCE. Frame relay route. Frame relay. What is the local route? What is the local del C? The local del C is 301. And then the remote interfaces serial 6/0. And the del C is 103. Likewise, go to the other interface serial 6/3. No shut. Encapsulation frame relay. Listen, I have not given any IP address on this. This is a switch. Frame relay. INTF type DC. Frame relay route. Frame relay route. Local is 401. Exit interface is serial 6/0 and 104. Then, now I'm expecting all three tunnels to be up. Show frame relay route. All are active. In 6 endpoints. Totally 6 endpoints. Which means 3 tunnels, all are active. Now if you go to R1, you will see that magic again. R1. You see all 3 has been discovered. So R1 knows the destination 103 very well. Now if I'll ping, wait, let me keep this one on the background. Look at this. It is asking like ARP, like, it is same like ARP, inverse ARP. This is called inverse ARP. In inverse ARP, it is asking who is so and so, del C number, all the stuff. All right, it's an inverse ARP. It says del C 15. Who is that? 101101. And for the frame relay, the hardware address is 1. So this type of MAC address discovery, inverse ARP. So there's a response here coming back. It's a frame relay. Del C's inverse ARP reply. Now, where we are going to now ping and test. So let me keep this at the background and I'm going to ping. Ping 10.0.0.2, which is router site 2. And I'm able to ping. Show frame relay map. I have a map. Show IP interface brief. It is up. Ping 10.1.0.2. I think I did a wrong ping. Earlier, I was pinging wrong address. Let me check. I missed that one here. You see, so using frame relay encapsulation, the ICMP packets are now going. You see, it's not Ethernet. It is frame relay. Frame relay is carrying this See, 102 is the del C number it is using, because that is the del C which will take you to router 2.
So there is no connection of the MAC address,
No
right?
MAC address. Instead of MAC address only we have this del C number. Now what I'm going to do is I'm going to ping another one, you see, 3. When I ping 3, you see del C number 103 is used. And return, you see, 103 to which it is returning. Now let us ping from here 104. Alright, I'm expecting 104 del C number instead of 103 when I finish pinging. Ping and click on this packet. Look at this 104. So the dynamically learned del C numbers are used to identify the tunnel endpoints, and you are able to ping. The frame relay is working very well. Now it's time to check OSPF. I told you the OSPF will not come up. Even though the reachability is there, even though OSPF is enabled, you see show IP OSPF interface brief, OSPF is enabled, but there is no neighbor discovered. Even on R2, if you check show IP OSPF, you see there is no neighbor. Show IP OSPF neighbor. OSPF is running, but it is not discovering any neighbor. Order 3. Show IP OSPF neighbor. See? Show IP OSPF interface brief, but OSPF is running. So because there is no hello packet from other, everyone calls themselves as DR here. Show IP. Now what I'm going to do is, I'm going to start configuring OSPF neighbors manually. Let's do that. I'm on R4. I'm going to say router OSPF 1. You got a neighbor called 10.1.0.1. When I hit enter, I want to see something on the background, so boom. From R4, I'm expecting some packet to come to negotiate. Still not it. Let's go to R1. Here also I'm going to say router. Look at this. I told you, no? After you give neighbor, only the neighbor will come. So the hello packets was sent from 4 to 1. And 1 responded back because it's a unique as will respond. And DBD's all the neighborship adjacency has come. You see, it has come, but it is recommended to do on either side. On R4 side, I said go and negotiate with R1. As a response, R1 negotiated back and neighborship has come. Okay. So I'm not going to do it on R1, but it is recommended to do on either side. The reason why okay, let's do it. Neighbor router OSPF 1. Neighbor is, it's already a neighbor, but I'm just doing it. So now show IP OSPF neighbor, I have OSPF. Neighbor router 4 is the DR. Now I'm going to router 3 to configure neighbor. Router OSPF 1, neighbor 10.1.0.1. Likewise on router 2, router OSPF 1, neighbor is 10.1.0.1. So we have found neighbor You will see router 3 has come, router 2 will also come now. Okay, router 2 has also come. And if you notice here, there is a DR BDR election. Who is a DR? Router 4 is a DR. Now, who is a BDR? Router 4 is a DR. If you go to router 4 and ask, show IP OSPF neighbor, it shows router 1 is a BDR. What is the use? If it is a hub and spoke, if one hub goes down, finish. So this is recommended only when it is full mesh. Now let us try pinging from R1 loopback to R2, 3, 4 loopback. Show IP route OSPF. Look at this. You learn route from R4. But not from anyone else. Why, you know? Because this is not a DR. Everyone will report to DR only. That's the problem. So to make it as DR, what do you do? Set the priority. Interface serial 6/0. IP OSPF priority 254. 255 is the maximum. Now what I'm going to do is I'm going to clear OSPF on R4 and R1. Clear IP OSPF process. See, to avoid all these unnecessary steps, you need to switch to the other type. Okay, you should switch to the next type because here it's not full mesh. Because of that, you are facing all this issue. And another reason why you are facing this is because there's a DR-BDR election. Okay, I'm waiting for. Okay, one more thing is I need to go and configure neighbor here also, all three neighbor router. OSPF1. We just configure only router 4 as a neighbor. Router 3 is also your neighbor, router 2 is also your neighbor. It's good to do it on either side. Now, show IP OSPF neighbor. Okay, they're all in attempt and two-way states. Wait for some time. I'm still expecting from R4. 4 has not yet come. It's still in an attempt state. With R1, I'm expecting everyone to have full relationship. You know why? Because I have given big priority. I have given big priority. Now I see one router. Okay, here R3 has become DR. How come? Okay, it shows that R4 is the DR now. No. I want to make R1 as the DR, so I gave I pride. See, all this confusion is because you don't have full mesh and you got DR BDR. One thing I can make this to solve this. I'll go and tell R2, R3, R4. Shh, don't participate. Don't participate in election. Let R1 be the DR. Don't participate. How do I say that? I can go to R1 and tell that the neighbor 2222 priority is 0. Even though his priority is 1, I'm saying, hey, we don't take We don't consider him to be a competitor. That's it. Now I'm going to do what? One more thing you can do is you can go to these interfaces and say priority 0. That is also much better. Clear IP OSPF process. See, you need to do all this unnecessary circus to solve the issue if you are sticking on to this default mode network type called non-broadcast. Show IP OSPF neighbor. Okay. Now let me finish doing this one also. Interface serial 6/0 IP OSPF priority. This will avoid unnecessary attempts of forming DR. Interface serial 6/0 IP OSPF network type. IP OSPF priority 0, which means this will not participate in election. Okay. Now let us cancel clear IP BGP, clear IP OSPF, clear IP OSPF process. Now, let's wait. This priority will remain 0 because we have configured as 0. Attempts are made. Okay, 1 to 4 is over. Now attempts are made between 4 and 1. Okay, this is hello packet. I can see OSPF allows us send only between, okay, even between 2 and 3. DVDs are also shared between, but most of the DVDs are between 4 and 1. I don't see the other ones. We need to wait for more time. This is frame relay. It is not that fast as you think. Still the neighbor has not come, you see. Frame relay map. Frame relay is good. Need to wait. That is why it is not recommended method. Which one? When it is not full mesh, having DRBDR is not recommended. See how long it takes. What all we did even after doing all those things. Okay, now something is happening. You see, the priority that I set there is 254. Now router 1 is the DR. Router 3 says router 1 is the DR. Not only router 3 says, even router 2 will say the same. Show IP OSP of neighbor. You see, router 2 is also saying, yeah, he's my DR because of the high priority. Even router 4 will say the same. All right, now if I go and check the routing table on R1, I should see all the roots. You see? Now only I can see all the roots. I made this as a DR to get this. Now let us go to router 2 and check the routing table. Show IP route OSPF. You see? You now know how to reach 4444 source source 2222. Now, as I ping, I would like to keep it at the background. These things to see the current status. Right, it's an ICMP packet I'm pinging from. Uh-oh. Why? Why are you not pinging? Show frame relay map. Again the problem. You see, that's why it is not recommended. You know why it is not pinging? This is the reason. You will see now itself for yourself. It says, in order to go to 4444, I need to go to 10.1.0.4. But because you don't have PVC with 4, because you don't have full mesh, you know only hub. You know only how to go this one. So if you ping that, it will ping. It will ping. But when you say you ping this one, even though you learn the route, when you say you ping this one, this is the gateway to which there is no frame relay map is present. See how difficult it is to you manage and force the normal behavior. The normal behavior of non-broadcast is this. So only when you have full mesh you can use it. See, only with frame relay I can teach all this. That's why I brought frame relay into picture and I explained you all this. So we'll remove all this extra configurations that we did, and then we'll switch to second type called point to multi-point, where there is no DR/PDR, and the neighbors are dynamically learned, and you will not have all these problems that you face here. Now, to solve this problem, I should write again another what? More frame relay maps, reaching 10, 0. That's not our business. You need to write frame relay maps for these things. Only then the problem is solved forever. But you don't need to do these things when you have other types which will make it easier for you. If you say, look at this, I don't want neighbor dynamic, then go with the third method. Neighbors will not be dynamically discovered. Yeah. So we'll do this.